welcome to a little video about angles in the unit circle. Now on the left hand side you should see our unit circle. It's blank. We'll fill it in together. The unit circle is located on our XY coordinate plane. We're not drawing in the grid because we need to label a bunch of other things. But just keep in mind that this is a circle that's drawn on an XY axis, kind of like this one, and all of the points that are on the circle are x comma y, they're coordinates. We'll get to that later. For now, we need to think of ways that we can solve for those coordinates. A circle in itself has 360 degrees, so theoretically we could use anything from 0 to 360 degrees to solve for coordinates. Now, we have found, or some very past smart mathematicians have found some very perfect angles when it comes to trigonometry. So perfect is relative here. They create some very convenient answers and they're just easier to work with. So if it's easier and more convenient, why not use it, thought the math community, and that's what we ended up doing. The angles that I'm talking about are the 30, 45, and 60, and of course 90 degree angles. The 90 represents our right angle, and when we have right angles in triangles, we are able to use some trigonometry. And trigonometry turns out to be quite useful in finding all of these coordinates. So, the first thing that we need to do is find the rest of the angles that are not labeled in this circle. They are all going to depend on that first quadrant. That first quadrant, and let's label it quadrant 1, has our reference angles. So anything that we do in quadrants 2, 3, 4 is with reference to the quadrant number 1. So, like I said, everything depends on quadrant 1. There is a pattern between these angles that we're going to find and follow. Okay, from 0 to 30, I add 30. From 30 to 45, I add 15. From 45 to 60, I add 15. And from 60 to 90, I add 30 again. And that pattern is going to get repeated all the way around. Let's do it. All right, 30. So 90 plus 30 is 120. Add 15, 135. Add 15, 150. Add 30, 180. And check that out. We just did half of a circle, 180 degrees. If a full circle is 360, half of it's 180. And it also forms a straight line. It's that x-axis, 180 degrees. Look at how all of this is related. So cool. Okay, let's continue. So again, 30, 15, 15, 30. Let's do it. Add 30. 210. Add 15. 225. Add 15. 240. Add 30. 270. Oh no, what did I just click? Uh-oh. You see that freaking out on me? Hold on, let's wait. Are you done freaking out? Okay, Control Z a couple of times. There we go. Nice, nice, nice. 270. 270 is 3/4 of a circle. That makes sense. Let's continue. 30, 15, 15, 30. 270 plus 30 is 300. Plus 15, 315. Plus 15, 330. And let's complete our circle, 360. Now, that looks kind of funky. 0 and 360 in the same spot? Well, yes, of course. Where we start a circle is where we finish it. That's the beauty of a circle in itself. We will generally refer to it as 0. You usually see it in math textbooks as 0 rather than 360. You will see it as 360 from time to time, of course. But the goal is to recognize that 0 and 360 are the same spot because the beginning is the same place as the end for a circle. All right. Now, the reference angles in the first quadrant. Oh, I forgot to label the rest of my quadrants. Quadrant 2, quadrant 3, and quadrant 4. Okay. Now, I just went counterclockwise. So I opened up to the left. And when we open up to the left, that's how we get our positive angles. All right? When we open to the right, we're going the opposite direction. That's how we get negative angles. The minus just telling us we're going the opposite direction. And that's what a negative symbol is in general. It means opposite. Okay. Now, the angles in the first quadrant are called reference angles for more than just this pattern. We can use these angles as like a multiple choice answer to all the other angles in our circle. Let's check this out. The first one I like to start with is 45. And one of the reasons I like it is because it's smack dab in the middle, so it's kind of easy to identify the rest of its references. And yeah, there's some other math stuff involved with it that we'll go over later. It's about the coordinates that makes me the happiest. But you'll see that later. Nerding out. Okay. All right. So every single angle that is in the middle, just like 45 degrees is referring to 45. So if I say, hey, what is the reference angle for 135 degrees? Well, you would look at the first quadrant, and the first quadrant has 45, so 45 degrees. If I ask you, hey, what's the reference angle for 225 degrees? You would say 45 degrees, because you would have looked at the first quadrant and seen that it's in the same spot as 45 degrees. And if I asked you, hey, what's the reference angle for 315 degrees? You would say 45, because you would have looked at the first quadrant and seen that it's the same location. Okay, next, let's do 60. Now, I like to do 60 before I do 30 because if you take a peek at all the ones that I marked up already, they are all divisible by 45. So 30 and 60 have similar things that they can be multiplied into. So I do the 60 first because everything that can be divisible by 60 is divisible by 30. But not everything that can be divisible by 30 is divisible by 60. So I want to eliminate the 60 ones first, and then we'll look at 30. Okay, so let's start with 60. If I say, hey, what is the reference angle for 120? That's 60 times 2. You would look at the first quadrant and you would say, it's 60. If I said, hey, what's the reference angle for 240? That's 60 times 4. You would say, oh, Miss Gumin, that's 60 degrees. That's 60 degrees. I'd say, oh, good. You must have looked at the first quadrant. And then if I say, hey, what is the reference angle for 300 degrees? You would say, hey, it's 60. Because I looked at the first quadrant and I'd be like, wow, good job. All right, last one. Let's do 30. This one's a little easier to see now that we've labeled the rest of them. The reference angle to 150 is 30. The reference angle to 110 is 30. And the reference angle for 330 is 30. Now, I want to do a line of this. Will that work? It will look a little weird, but that's fine. That's okay. It won't be solid. It's transparent. Sometimes you gotta be different. That's okay. Boom. Now we do have some angles that are not highlighted. Let's do that. We have a reference, our 0 and 90 and 270. So when we're looking at these, they're a little different. They are related to each other. If you take a peek, they all go by 90s, and they're at the perfect placements. All of these are actually perfect coordinates. Right here is 1, 0, negative 1, 0, 0, 1, and 0, negative 1. So these are all perfect 90 degrees. So that's how they're kind of related to each other. They're not necessarily called reference angles. We generally use 30, 45, and 60 when we refer to reference angles. But they are good to see that pattern and relate to it. Okay. Now another thing that we're going to do with angles is find positive and negative coterminal angles. Now all this means is co means so together, kind of. I'm not sure if that's the exact definition, but terminal means the end. So we're going to find two other angles that end in the same spot as the one that I'm asking you about. Now, how is that possible? Well, it's a circle. You can go round and round in circles as many times as you'd like. I can't. I get dizzy and vomit, so no circles for me. But I'll imagine myself going in circles, not too fast, because okay, maybe thinking about it makes me a little dizzy too. All right, so to find a positive coterminal angle, we will add 360 to whatever angle we have. To find a negative one, we subtract. And this little note says what I just said. We can add and subtract as many times as we want. Now, what does this mean? What does that look like other than just adding and subtracting? Hey, thank you. Oh, I was drawing, I see. So when we're opening, well, let me just make an arbitrary angle. Here. Let's say we are already here. When I say, hey, add 360, that means I'm going counterclockwise and ending up in the same spot. So we add 360 degrees to that. And we find out how many degrees I've traveled. Now, I forgot to mention that we've already traveled this distance, right? Okay. Now, when we are subtracting 360, we're actually saying, hey, let's go the opposite direction. So instead, we are opening downwards to the right. And we get a negative answer. Again, the negative says we just went in the opposite direction. That's what it's signifying. So instead of walking circles to your left, you start walking circles to your right. Okie dokie. Let's do it. All right, 45 degrees. Let's find the coterminal angle there. That means I'll add 360. So that's 405 degrees. And subtract 360. That's negative 315. All right, I'm going to try and showing you this, but this might look a little busy because you can't really see me or my hand motions. All right, so if we are at 45 degrees, so we've already traveled from 0 to 45, counterclockwise, and I say add 360, that means go around again. And we've done 405. When I say subtract 360, that means I'm going to go from 45 backwards. And that would be 315 degrees. The reason is, if you kind of see, I went up 3 quadrants around. If you look at this quadrant right here, if we go 3 quadrants from 45 the positive way, we get to 315. So technically we traveled backwards 315 degrees to get to 45. So that is what's happening. I'm trying to erase this, but it's not working. But all we really need to do is the arithmetic. Well, let's do 270, and I think we'll be pretty good. All right, 270 plus 360. This sounds crazy, but it's going to be 630 degrees. But we've already traveled 270, so that makes sense. All right, let's subtract. Let's go the opposite direction. Let's do 270 minus 360. I hope you guys can't hear that crazy beeping right now. Oh! I may have dropped my camera, but that's fine. Negative 90 degrees. There we go. All right. You have your two angles. It's okay that it's negative, remember? That just means we're going the opposite direction. And yeah, that's it that I want to make this video about. I hope that helped. If not, please ask me or your teacher any other questions that you have. Have a wonderful rest of whatever day it is for you. Bye.